Here are a few examples of our sustainable design. Our very first project, Faversham Gym Club, completed in 2003, incorporates a central light and ventilation turret in the gymnastic hall to provide natural daylight and passive stack ventilation as an alternative to air conditioning. Gravesend Borough Market and Gravesend Library are end of the 19th century, beginning of the 20th century buildings by local architect Edmund J. Bennett. Both historic buildings feature Edwardian sustainable design strategies for passive stack ventilation and natural daylight. In Gravesend Borough Market, we refurbished and insulated the roof of the hall and installed new double-glazed roof lights where the original roof lights had been removed in the 1970s. The new roof lights have solar glass on the south side to reduce solar heat gain. We refurbished the roof-level timber louvers and fitted the internal timber shutters with actuators and a simple manual control so that the shutters can be opened to air the market hall. Gas-fired ambirads warm objects and people, not the air. In Gravesend Library, we installed replacement roof lanterns with solar glass to improve natural light while reducing solar heat gain. The roof lanterns of the historic library and rear windows and front facade of the new extension are fitted with automated dampers, connected to thermostats and CO2 sensors, which control passive stack ventilation through and between the connected main spaces of the original library and new extension. The conversion of Cranbrook School's 1960s gymnasium into a new sixth form centre is an example of a more stripped back, relatively low-tech approach. Fresh air for the passive stack ventilation system is simply obtained by manually opening the louvers on the new north-facing windows. The new south-facing windows have solar glass to reduce overheating in summer. Natural thermal fleece insulates the underside of the roof, improving thermal performance and also improving acoustics in the study area. Walder State Primary School, rated BREEAM Very Good, is a new build and an example of a more integrated approach. It incorporates acoustically attenuated passive stack ventilation with night cooling, large roof lights and north-facing windows for good quality natural light to the single-aspect building cut into the hillside, solar glazing and automated blinds to the south-facing roof lights to reduce solar heat gain, an intensive green roof for outdoor play, which also insulates the building and reduces rainwater runoff, 164 square meters of photovoltaic roof panels to reduce the building's carbon footprint by 23%, fully automated lighting system. Medway Crematorium involves a mixed-mode, passively ventilated chapel extension, supplemented with comfort cooling and a purge function to deal with CO2 buildup during services of large numbers of people. Acoustic attenuation cuts out the sound of the nearby M2 motorway. We have been researching and developing a prototype sustainable house design that can be adapted to any new house or housing project. The houses will be built of precast hempcrete, a natural vapor-permeable hygroscopic building material which combines good insulation properties with great thermal mass. Natural and passive stack ventilation will enable the house to breathe naturally and, combined with the hempcrete's high thermal mass, even out internal temperature fluctuations and enable night cooling. The performance parameters of the house will be optimized through dynamic simulation modeling so that the house performs well in terms of temperature, airflow and light even if it was disconnected from all active energy sources.